Um, we're starting the webinar. So, good evening, everyone. Uh, welcome to today's webinar on optimized disinfection solutions for safer municipal drinking water. I am Suma, and I'm the marketing and communications leader for Evoqua Water Technologies for the India and South Asia region. Moving on, this is the introduction of the today's webinar. The speakers for today's webinar is Mr. Shailesh Pawar. He's the Senior Product Manager for Wallace and Tiernan Products of Evoqua Water Technologies. He has got a wide experience in municipal wastewater and drinking water segment. Followed by Ms. Remeya Surendran. She's a technical sales support for South Asia region. She had a wide experience in the chlorination segment in Evoqua Water Technologies. Now, the presentation for this webinar will be covered in 1 hour, and that includes the question and answer session for the for the next 15 minutes. So the question and answers can be addressed in the last 15 minutes. Mr. Shailesh Pawar, he will be introducing our new product, that is emergency shut-off drive product, and Ramya Surendran will cover the introduction part of gas chlorination. The learning objectives for this webinar would be to understand the importance of chlorine gas storage and Evoqua's unparalleled product portfolio with a proven brand of Wallace and Tiernan products. Also to understand the diverse options available for chlorine storage and which are the safest methods available to keep the surroundings safer. And also to understand the importance of chlorine container safety in water treatment plants and how we can do that with our proven product, emergency shut-off drive. Before we start the product presentation, I would like to take you to a brief overview of Evoqua. Starting with Evoqua at a glance. Evoqua Water Technologies is a leader in water and wastewater treatment solutions provided. We have close to 4,500 employees across the globe, with close to plants and factories in close to 150 plus locations, and we have around 38,000 customers spread across the globe with more than 200,000 installations worldwide. We have offices in 10 countries. And as of September 2022, we are $1.74 billion revenue making organizations. Moving on, this is a big news in water industry. The two water leaders are one now. That is, Evoqua has joined Xylem. This is a creative, transformative platform for advanced water solutions. With Xylem and Evoqua coming together, we are here to address and solve the critical water challenges faced by our customers, communities, and the planet. So this is the technology evolution of our products, starting from 1913, which is from where the story begins. Like our first installation of Chlorinator began in 1913, and by 1918, more than 1,000 plus cities in the US started using sodium hypochlorite. And in 1957, the pioneer Dr. Henry Baer applied for the patent of titanium anode. And in 1963, the Evaporator surface aerator was introduced. By 1980, the first OSEC, that is on-site hypochlorite generation system, was introduced, and in 1987, Iron Pure, this is our renowned brand, commercialized the CEDI technology in the market. In 1990, US filter was established, and in 2004, Siemens acquired US filter. 2004, again, we introduced a new model of Iron Pure LXHI model in the market, and in 2007, we came up with a new model of VNX EX model in the market. In 2007, Siemens acquired SG Lab Water System. This is the lab water segment of Siemens. And in 2008, Biomag magnetite ballasted treatment system was introduced in the market. In 2014, AEA investors acquired Siemens Water. And by 2014, Evoqua Water Technologies was established as a brand. In 2016, we acquired Neptune Benzene. It is a patented product it is a well-known brand in the aquatics market for the filtration of the pool water. In 2017, we listed ourselves in New York Stock Exchange. By 2018 and 19, it was a year of acquisition and new product innovation. Like 2018 was a year where we acquired Pacific Ozone Technology, and 2019 we acquired ATG UV system. In 2021, we came up with the two new products under the ATG UV brand called VXVT, and under the Pacific Ozone brand, we came up with Powertron product. Moving on to the next slide. So Evoqua operates on the two key segments. So one is the integrator solutions and services, and other one is applied product technologies. When we talk about integrator solutions and services, it's basically a customer-facing project and services organization. And when we talk about applied product technologies, it is primarily focused on sales through direct channel partners. We supply to many key sectors, which starts from healthcare and pharma, food and beverage, light and general manufacturing industries, microelectronics, municipal drinking water and wastewater, and power industries, aquatics and pools, refining and chemicals, and commercial industries. So we are spread across a diverse industrial segments. Moving on, this is our commitment to the sustainability, and we want to positively impact the human health and wellness in an everyday life. Our products, as the world is moving towards a more circular and sustainable economy, we are well positioned to help our customers achieve their sustainable goals. Our products are well aligned with the United Nations Sustainable Development Goals, and this allows our customers to create a more sustainable future and increase their sustainable index. This is our geographical spread around the world. So we are headquartered in Pittsburgh, Pennsylvania. We have more than 100 plus offices in US. That includes the plants and factories. We have presence in global level with more than presence in 10 countries and 150 locations. That includes the plants, offices, and factories as well. So we are spread across Australia, Canada, China, India, Germany, Italy, Singapore, and UK. We opened our engineering technology center in India, in Chennai, in 2019. Moving on, we serve to a very large, growing, and fragmented market. So we have renowned brands for different verticals and different product verticals for the different segments. So starting with our patented brand, that is Iron Pure. A patented brand, that is Iron Pure. Under Iron Pure, we have continuous electrode deionization product. We have supplied these products to Samsung, Toyota, and Toshiba. And under electrochlorination, we have Chloropack brand, under which the product is sodium hypochlorite generating system. We have supplied this to brands like Tata, ONGC, and Shell. Wallace & brand. Under this, we have products like gas feed and ESD, OSEC, analyzers, and controllers. We have supplied to government bodies like MIDC and RCF, and corporate bodies like Tata as well. Under the ATG UV system, we have products like Wafer and SX series, and we have supplied to brands like Petronas, Kane, Total, and Dong Energy. Pacific Ozone, mainly we have supplied to the food and beverage industries, like for the brands like Coca-Cola, Pepsi, and P&G. Under the lab water systems, we have more than 1,050 working installations in India, and we have 100% territory coverage with our reputed channel partners. With this, I end the corporate presentation, and I wish you all the happy learning for the next presentation, which I would like to call upon Mr. Ramya Surendran to take over the gas chlorination presentation. Over to you, Ramya.
Yeah. Thank you, Suma. Thank you, everyone, for joining the webinar today with us. So in this segment, we'll just cover the brief about gas feed chlorination. It will be a refresher and the basic components of the gas feed chlorination, the typical installation, and what Evoqua can offer under the gas feed technology. Yeah, next slide, please. Yeah, so to begin with, let's just see why we chlorinate our water. Chlorination is not a new process. In fact, it has been used in both the municipal and industrial application for more than 100 years now. So some of the reason may be aesthetic, like the iron and the manganese removal, and the taste and odor treatment, which is caused because of the contaminants present in the wastewater. Some can be a serious issues like the bacteria, which can be which can pose health issues to humans. Then algae can be odor causing, and some of the algae can be toxic also. Then we have hydrogen sulfide or H2S gas, which is found mostly in the sewage collection systems. To sum up, actually, above all these reasons, the law is the main reason for the disinfection, and chlorination has always remained the most common form of disinfection in most of the countries. Next slide, please. So how does chlorination work? So chlorine, as we know, is a very powerful oxidizing agent, and it is a very effective disinfectant. So once it is added in the public water supply lines, it kills the pathogens that is commonly grown in the water supply, in the water reservoirs, on the main water lines, and in the storage tanks. So the basic principle how it works is chlorine, it reacts with water after the hydrolysis process. It forms the hypochlorous acid. The hypochlorous acid is neutrally charged, and it disintegrates on the cell wall of the microorganisms, and it reacts directly with the cell enzymes and the proteins and make it non-functional. Eventually, these organisms die, or it loses its ability to multiply. So this is a basic principle of chlorination. Next slide, please. The available types of chlorination, what we see in general are the gas feed chlorination. Gas chlorination uses 100% of gaseous elemental chlorine, which is diffused into the solutions and is directly delivered into the water treatment process. Then we have the standard liquid feed chlorination that uses the sodium hypo, which is seen at the concentration of 12 to 15 percentage, which are stored at site in the bulk storage tanks and utilized in the water treatment process. Then in the sodium form, we have the solid form, we have the calcium and the calcium hypochlorite, which is also called as bleach, which is present at the higher concentration of 60%, and which is stored in the preparation tanks, diluted and dosed in the water treatment process. Then we have the OSEC system. The OSEC is a word which was originally coined by Wallace and Tiernan for the on-site electrolytic chlorination. It is a process of generating low concentration of sodium hypochlorite of 0.6 to 0.8% at site from salt, water, and electricity. These are generated and stored in the special tanks and dosed at the point of application through metering pumps. So in this webinar, we will focus a little more on the gas feed chlorination system. Next slide, please. Yeah. So this slide covers the the Wallace and Tiernan's legacy in the chlorination, which began 100 years ago with one of the most significant breakthrough in the public health advancement of the millennium. And in 1930, we installed the first chlorinator for the public drinking water treatment system. So after that, there had been many advancements. We moved from the pressure-driven system to the vacuum-driven system. Even today, it continues to be the latest in the gas chlorination, disinfection, and chemical dosing system packages. So Evoqua's gas feed and the residual monitoring technologies continue to set the benchmark for a safe and reliable drinking water purification. Yeah, we'll take a quick poll here. Please help me with the answers. The question is on your screen. Are you aware of the Wallace and Tiernan brand for disinfection product? The poll must be open now. Yeah, thank you. Thank you for that. I see it's like it's a 50-50 there, and few of like 50% of the poll says that people are aware of the WNT brand for the disinfection product. It is a good news. So let's move on to the next slide. Yeah. So under gas feed chlorination system, we have some basic components which is required to dose the chlorine gas into the water treatment line. So it starts with the gas supply. So the chlorine gas is supplied through the cylinders or drums or the evaporators. Then we require the differential regulating valve or the pressure relief valve, followed by the chlorinator, which is equipped with the gas flow meter and the feed control valve to control the amount of chlorine gas dosed. Then we have the injector system and the booster pump. So how does the vacuum chlorinator system work? In a vacuum chlorinator system, the chlorine gas is pulled from the cylinder and it is introduced onto the water source all by vacuum. The vacuum is created when the water flowing through the injector, it creates a negative head, and this negative head drives the pressure regulating valve to open and allows the chlorine gas to flow out of the cylinder into the chlorinator. So once the gas is entered to the chlorinator, the chlorine feed rate is measured using the indicator known as rotameter. Just beyond the rotameter, the chlorine gas flow past the regulating device or the V notch that controls the amount of the chlorine feed rate. Then the chlorine gas is pulled into the injector. The injector is also called as the ejector. The injector consists of the pipe with the water flowing continuously. So the flowing water pulls the chlorine into the water, both chlorinating the source water and also creating the vacuum in the entire process. The chlorine gas is dissolved in the small amount of source water, which is then piped into the main line of water to be chlorinated. So this covers in brief the entire process of how the vacuum chlorinator operates. So the booster pump here, it provides the required flow and pressure for the injector operation. Yes, next slide, please. So the chlorine gas supply is through small cylinders. So if you see, the less than 100 kg per cylinder can be utilized for wherever the application requires 226 kg or less per day. And these special cylinders are used only for gas delivery. And these are equipped with special header valves and the fuse tubes for a safety. And these are shipped with 80% liquid chlorine and 20% vapor space is allowed for the thermal expansion. Next slide, please. For larger application, we have the ton containers, which is around 1000 kg net weight. So these are used for application where the requirement is more than 226 kg per day. And the similar, it has the fuse tubes and the special header valves equipped in the ton container. And these also follow the same norms, like it is shipped with 80% filled liquid chlorine and 20% vapor space for the thermal expansion. One of the critical parameter which is to be followed for both the cylinder and the ton container is a gas withdrawal rate. So these should be followed as per the local regulations and the manufacturer's guidelines. Yeah. Next slide, please, Suma. Yeah. So this flow diagram, shows for the typical small feed gas system. So you can see from 0.2 to 10 kg per hour gas system. Here, if you see, we have two cylinders which is manifold together into a common header line with the vacuum regulator directly mounted on the cylinder. So with this, we are converting the pressure line to a vacuum PVC line, which is directly connected to the control unit, followed by the injector with the water supply and the point of application. The number of cylinders which can be connected in a manifold can be increased, but there are the criteria for the maximum number of cylinder that can be put under a manifold, and that has to be followed strictly. Yeah, next slide, please. So this is for the medium size system, typically for about 10 kg to 40 kg per hour. Here we see a 4-ton container which is manifold together to the gas header, which is in turn connected to the drip plug and the strainer and the vacuum regulator. So if you see in this case, before the vacuum regulator line, it's a pressure line. But alternatively, we can mount the vacuum regulator valve on the container also directly and get it converted into a vacuum driven PVC manifold line also. And later it can be connected directly to a control unit and the injector system. Yes. Next slide, please. Yeah. So this slide, we wanted to highlight on the different models of the vacuum chlorinators which Evoqua can offer. Our capacity ranges from 3 ppd to 10,000 ppd. Okay, that is from 0.06 kg per hour to 200 kg per hour. As you see, we have it begins with the S10 case, which can be provided for the capacity till 10 kg per hour. The S stands for sonically regulated vacuum feeder. So Evacua's vacuum chlorinators can be categorized into two segments, that is sonically regulated and differential regulated system. Sonically regulated system is an economical option for the capacity of till the capacity of 10 kg per hour, where the vacuum requirement is more and hence the motive water pump capacity is more. So but we have kept our differentially regulated technology or the vacuum regulator in place. It provides a more economical and quite reliable and accurate operation with the differential regulated valve. So it is the V10K system and the V2000 series system is all the differential regulated series. In our case, like if you see many competitors or the other manufacturers have already moved from the differential regulated to sonically regulated model, compromising on the safety and the performance aspect of the gas chlorinators. So but we still have kept the old technology intact, and we believe in providing a more safer and a reliable technology to our customer. Next slide. So to summarize the benefits of WNT gas feed system, as we discussed, we use the V-notch gas flow technology, which provides better accuracy and repeatability. It's all vacuum operation. So when there is a cutoff in the vacuum, the gas supply is cut off, hence ensuring a complete safe operation. And these chlorinators come on the wall mounted configuration and also the floor mounted configuration. Based upon the site configuration, we can give you the appropriate design. And the capacity ranges from 3 to 10,000 ppd, that is maximum of 200 kg per hour, with the 5-inch and 10-inch rotameter scale. We also have the built-in automatic switch over system in our vacuum regulator, which helps you switch between the empty and the full cylinders automatically. And we also have the automatic and the manual control options available on our chlorinators. And these, other than the chlorine gas, these chlorinators also, these systems can be used for other water treatment gases such as ammonia, sulfur dioxide, and carbon dioxide. They are very reliable and high endurance for premium constructions. And serviceability is good. Without any special tools, you can manage the system. And as we discussed, the differential type regulation is available in our V10K system and V2000 models, which can operate in the lower vacuum levels and provide a more economical injector options. Next slide, please. So other than our chlorinator, we have the evaporation system. So evaporation system is basically it's an we can call it as an vaporizer also, which is usually used to convert the liquid chlorine to a gaseous form. And here, if you see the weight of one volume liquid chlorine is equal to 457 times of its gas at 0 degree centigrade. So this offers a lot of operational easiness to when we have higher capacity plants, we can use the liquid chlorine and get it converted into the gas chlorine at this site. So Evoqua also has its 5200 evaporator series, which is designed as per the ASME code mandate, and the guidelines are followed as per the Chlorine Institute guidelines for evaporator to avoid any potential hazard. So this slide actually covers other accessories which support the evaporator operation. We have the pressure relief valve, the gas strainer, the connections, the liquid changeover manifold. So other than that, the new addition to our gas feed product portfolio on the safety aspect is the emergency shut-off drive. So emergency shut-off drive, which is mounted on the cylinder directly, it works in tandem with the chlorine gas detection system, and it shuts off the gas release in case of emergency. So in the next segment, we will go through about the emergency shut-off drive in detail. Shailesh will talk us through the emergency shut-off drive. So before that, we have our next poll question. So just I request you to have a look onto the question and give an appropriate answer. What is the current technology used for disinfection in your water treatment system? Yeah, I see the answers are here. So the gas feed is known, and more than 60% of the our poll result shows that we still use the gas feed technology. I'm happy to know that. Yeah. Yes, so thank you for the for answering the poll questions, and thank you for listening. I'll hand it over to Suma for the next segment. Thank you, Suma. Thank you, everyone.
Thank you so much, Remya, for a very good presentation and an overview about gas feed technology. And as I can see that there are 60% who is using 60% of the audience who are using gas feed technology. And with this, we can know that how important it is to control, and I mean how important it is to have a safer environment across it. So that is where the emergency shut-off drive, this product comes into the picture. So I will hand it over to Mr. Shailesh Pawar to take us through the ESG presentation. Over to you, Shailesh.
Thank you both. First of all, Suma, for that introduction. Apologize, I could not join some technical issues here, but I could start from, I think, 3-4 minutes late. Thank you, Remya, for setting up the stage. It was a proper introduction of the gas feed technology. I'm glad that audience 60% of it is aware of the technology and using it. Probably the rest of 40% using commercial or on-site or hypo thing. For them, this is something new. But then for the world, the technology is not new. It's been there for 100+ years, and we, as Evaporator, Volunteer, try to improve on the technical features, safety aspects of it. So in that context, additional equipment that we see here is emergency shut-off drive, which we also call AD as an ESD. And we will see in next couple of minutes, what does it mean, why it's been here, and what we are trying to achieve through that. Next slide, please. So just quickly, the contents. So here I'm going to speak about the ESD, the introduction, the safety measures so far the world has seen, and then the main question, why is the ESD? What is the difference between us and others like Volunteer and ESD? What are the technical features? Which variants that we are addressing, and what is our current reference of installation? Next slide, please. Next slide, please. Yeah, so when it all started using chlorine gas in water treatment as, sorry?
There's a lag, you can go ahead.
Yeah, I hope you can hear me.
Yes.
Using chlorine gas in water treatment usage, the first thing came in mind is chlorine being the hazardous chemical, and how it can be contain when it comes as a leakage. So first thing first appear is the emergency kits, which you can see on the left side of the slide, comes with kit A, kit B, kit C. So typically, if the cylinder is of small capacity, anything between 35 kg to 100 kg, there are special kits for A. If the capacity goes above, in some countries it's from 500 kg, 800 kg to 1000 kg, then the kit B are used. And these are global standardized kits. So whether you are in US or you will be in India or any place, those kits are very much standard. And kit C is typically for the commercial use where the manufacturer of chlorine goes to a reseller or distributor and then a bulk chlorine is being transferred. So having said that, the next stage came into the water treatment specifically is on the neutralization of it. So there were two types of scrubbers. One first was like a wet media scrubber, which typically uses 20% of caustic soda as a medium to neutralize the weak chlorine. So it's a very basic base plus acid or alkali plus acid reaction. You mix chlorine with NaOH, you get NaCl plus H2O. So that's a completely neutralized thing. And then there is also an option of the dry media scrubber, which obviously uses the media which is in a dry format, but then there are so many disadvantages of it. You can't monitor the strength of the media and things like that. So without going into much details of those scrubber units, because then it's been shifted now in today's emergency drives. So it all started with the pneumatic systems, wherein you actually have compressor receivers with reserved air pressure, which is then get released through a control panel. Those control panels are solenoid valve based. So whenever the panel gets signal from the leak detection system, the solenoid valve opens, the air gets allowed through the pneumatic piping through the air motor, and the air motor with the actuator or adapter sitting directly on the cylinder or drum closes that particular drum or valve. So this was a great technology at the point of time, but then realization is it takes a lot of space. As you can see, these compressor receiver units are very bulky, they occupy a lot of space. Then you need to have installed a pneumatic piping system for that. You need to have a very bulky control panel. So what is the advanced technology to that? And then we come to the emergency or electric shut-off system, where you can eliminate those pneumatic tanks, piping, and additional operation and maintenance issues. And that's the background of the safety measures for chlorine cylinders or drums for so far. And hence we have moved to develop our own product. And we will see what are other reasons behind it. Next slide, please. So why ESD? So it all actually for us, it started when there were amendments done in DIN, that is German Standard 19606, which governs the specifications on the chlorine applications. So it's on the equipments, on the chemicals, on the safety system of it. So when they have amended 2 years back, asking to make it mandatory to have emergency shutout drive, at least for the drums which are 500 kg and above. Even the smaller cylinder users started looking at it and then said, why not we also implement that kind of system in us? So the demand was driving us on the direction to have our own product. Being Wallis-St. a reputable and a responsible manufacturer in gas feed industry, we decided to go with our own product without compromising on the quality safety issue of it. Obviously, whenever a manufacturer goes in the market, he looks around who are the players. We did that. We have compared the features, but then there was always a differentiation, and we'll explain how that differentiation is with us. Also, as you know, Chlorine Institute is the world's guideline organization which is always looking and revising their recommendations, or looking at currently how they can provide the guidelines to the chlorine users or end users to implement these kind of systems. And I'm hopeful that in the next couple of months, those guidelines will be available for in public domain. We also have observed a couple of inclusions in Middle East and some Asian countries about the mandatory inclusion of ESD systems, which is making you as bundle project, and hence that is another driving force for us to think on the product line. And then there are various other reasons like Australian standard switching of from pneumatic to electric one from the end user side, mainly because of the maintenance issue and the cost of it. Looking from the business partner or end user perspective, it's a cost control because you get compact system both on the capex and opex side, and obviously since it is a compact, it needs a very small footprint as such. This indirectly also helps you to reduce the cost on installation and man hours. So ultimately, suggestions from lot many end users to WNT that you already have a high quality product under gas feed. Why can't you include the safety product under your umbrella? And that would give us peace of mind. And those are the whys behind bringing this ESD to the market. Next slide, please. Okay, so that's the poll, I guess. What is the current technology used for chlorine gas leak detection and emergency control in your water treatment plant? We launched the poll herewith, which gives you basically two options. One is manual intervention, and second is automatic leak detection. So, I mean, are there any methods implemented, or the poll is open, I believe. Okay, I could not see the results actually, but then if you can.
It says, yes, Shailesh, it's 21% manual intervention and 79% automatic leak detection.
Okay. Thank you for that feedback. We will come back on that. I mean, addressing that 21% definitely, and on that 71%, how that automatic detection happens, whether it is only detection or even the prevention measure of it is. Okay, next slide, please. Yeah. So when we are looking at the ESD, what's our value proposition to the market? So first thing first, it comes in our mind when we deal with the chlorine, that is a hazardous gas. Nobody is denying that fact, but then it is a necessary evil. Hence, we have to deal that with respect. Hence, the first thing comes as a safety. When you are looking at the safety equipments, the aspects on those design around that particular chemical, that particular application, and the people who are dealing it. So we know most of these installation goes in a municipal segment or wastewater area where the operator maintenance levels are not that high, but then we need to keep on running those plants in a very safe manner. So for us, safety is the first thing. And when we talk about the Volsinian and safety drive, we assure you that whenever there is a signal from the leak detection system, The drive closes within 3 seconds, the cylinder or drum wall, whichever is in process. Second thing comes in usability, because this is not a one-time use. These plants operate 24/7, and hence the features should match to those requirements for the process. It should have appropriate battery backup. It should be having a user-friendly software. It should have a minimum downtime, and hence those things being considered while we are designing on the ESD side. And finally, and very important, is on reliability, because the performance needs to be consistent and repeatable. So when we are saying that we are bringing a product, it is backed by our strong experienced engineering team in Günzburg, Germany. And obviously, when we are looking at the standard, the first thing, since it is getting manufactured in Germany, this is CE marked. This follows complete DIN standards. We are also looking for CIL standards, for example, CIL rating in UK. And then obviously the baseline is the guidelines from Chlorine Institute. So this is fully compliant product when it comes to that. So that's our basically value proposition for this product in the market. Next slide, please. So when you are looking at the technical features, so on the left-hand side, the pictures, and these are combination we purposely added just to give a clarity to the audience that the emergency shutout drives can be mounted with or without vacuum regulator. When we say with vacuum regulator, there are various types of vacuum regulator. I mean, even within Evoqua, we have two types of vacuum regulators. As you see, one is specifically used in certain countries, metallic type. On the other side, there is a preference for non-metallic vacuum regulators. So it accommodates both the types. And even if, for example, if you are using some other manufacturer's vacuum regulator, there should not be a problem adding a ESD in that system. So it has no such limitation that you have to use A, B, C type of regulators and then only you can do it. It's a flexible adaptation. And then another picture shows that you can even adapt on the horizontal drums of high capacity, whether that drum is with heating or heater and triplet or assembly. It is possible to include that emergency drive in it. So there is no limitation on the installation side of it. We look at the various variants, and I'll show in a couple of slides that what variants we are looking at. But then looking at the APAC region, I'm confident that we will be able to cover most of the valve variants that's available in your market. So next is on the torque level. As we know, the torque level used in European countries are low compared to North American or even the APAC region. So we have selected that the higher torque level, which goes up to maximum 40 Newton meter. We are not so far came across for that high, but then definitely 30 Newton meter. These are pre-programmed, so our drive is intelligent. It's not just taking the signal and the motor is rotating. The electronic sits itself in the drive, so that's the differentiation between us and any other manufacturer in the world. As I mentioned, is a closure guaranteed within 3 seconds. And then we also follow if there are any regional regulations, requirements required. Obviously, there are so many drums or wall manufacturers, suppliers, we won't be able to satisfy each and every supplier, but then we have looked at the volume business where the majority suppliers are coming in picture to address that particular need. The control panel, which is again based PLC based, we use Siemens PLC. We had a Siemens background, and we believe that every component coming in the system should come from high quality manufacturer. So no compromise on the quality of it. There is a multicolor HMI display, which is again Siemens compatible with the PLC. We recently have also included 4 hardwired alarms, and that is purely based on the feedback that we received from our various customers based in various countries, because lot many water treatment plants are 50 plus years in operation. Those are having relay-based control panel, and then they are not able to take the telemetric signals. So they requested, why not you include those hardwired signal, which would help us to accommodate those systems, and hence we did that. The battery backup is standard is 12 hours, but that can be extended to 24 hours if the end user or the regional requirement comes in. The another features are on the low battery monitoring system and data exchange. Some of it is by default, and some of are optional, like for example, Profibus DP coming into the requirements. Next slide, please. So these are the variants I was talking about earlier. So it's basically divided into two categories, as you know, the vertical cylinder small capacity, which can be 35, 65, or even 100 kgs, and then the drums, which comes in 500, 800, or in India we call it 907 kg, 1000 kgs, which mostly comes with the standard local valves. So we looked at who are the drum suppliers and who are the valve suppliers, and have developed the adapters accordingly. So on the left hand side, extreme left, you can see the picture of the drive. On the right hand side is the control panel, which is neatly wired, followed the standards. You can see there is a proper space for operating and handling of internal components as well. Next slide, please. So this is a typical technical data sheet that we provide with each and every equipment. I'm just including some of this documentation here to make you sure that what is being behind the product documentation is well done. So that gives you an idea like what should be the operating temperature, for example, where you are going to mount it, what would be the dimension of it, what kind of cable length you are going to get it. And then you see on the right hand side a small PID type of drawing where you are seeing 8 components there. So basically the component number 1 is the cylinder, which is chlorine cylinder on which the vacuum regulator is fitted. Component number 3 is the line which is going to the chlorinator or gas feed side. Number 5 is the actual drive of the ESD. Number 6 is the control panel of the ESD, which we have seen in previous slide picture. 7 is the detecting sensor, and 8 is the gas monitoring system. So it's very simple, straightforward process. Whenever the sensor number 7 senses any leak in any part of the plant, it gives a signal to the amplifier, its own amplifier. That amplifier then triggers the control panel, which gives the control signal to the actuator to close down. So very straightforward, simple application, and easily or user-friendly way designed. Next slide, please. Another literature specifically used for marketing sales side to show that what features are included, and it highlights what are the requirement application and where you can use it. So it's a properly documented product, which would help specifically if you are facing customer, and we do have some kind of supporting presentations on that, which can be made available on request. Next slide, please. Another addition in here on the instruction manuals. So there will be detailed instruction manuals. Currently, we are having in English, Germany, and French. If required, that can be translated in the local language but then I believe impact is mostly on the English side, so we shouldn't be having problem. I purposely included this slide just to highlight audience that this detailed manual would give you not only highlights of the equipment of the system, but going into the component level. It's not only giving you just a wiring diagram, but how it is being configured specifically on telemetry side. That gives a complete detailing. Hence, your dependence on the supplier is much lesser. Having said that, we are not going away from the responsibility of not supporting it, but locally having those kind of details is always helpful. Next slide, please. So yeah, I mean, this is just beginning of this new product. As you can see, within 1 year's time, we have almost 103 systems going into the various countries. Since this all started from Germany, the number of installation in Germany is high. And as I mentioned earlier, that Australian standards changed, so they have started uh, placing the new ESD. So we are already placed on 14 sites, 30 more sites are under installation, and then you can see the different countries. We have recently have introduced it in India, is under installation. And while we speak, we got a nice job in UK where we are going to install another 20 systems on Thames Water. So this is happening across the world. This is not something new. People wanted to use chlorine gas because of the economics of disinfection, because of the local availability of disinfection, and because of the people who are operating this plant for so many years are aware of how to handle those kind of hazardous chemical. But then it's always better to have a safety system to make them sure that in the plant where you are um, operating or maintaining it is safe, and that gives a peace of mind. I think with that, I know we are running a bit on the Q&A hour. So with the next slide, I would like to conclude. Yeah, so these are a couple of installation pictures. We do have installation in different countries, as I showed earlier, but then we only are allowed to bring the picture in public domain where the end user gives you express permission. So these are from our German installation. Next slide, please. And again, these are for chlorine drums, which you can see looks a bit complicated because the end user requirement, apart from the vacuum regulator, also to include pressure gauges to monitor residual pressure in the drum, because they do not want the drum to run completely empty. So when the pressure goes to less than 1 bar or zero point 0.5 bar, actually the stoppage signal stops it from withdrawing. That way, there will be always a small pressure maintenance cylinder, not to allow the humidity or the water content from the air to enter in the cylinder and prevent it from the corrosion. And then you can see also the drip leg assembly, and then there is a heater arrangement. So it was a small challenge to build that unit, but then we could manage, and you can see the ESD is already mounted there. So these kind of installations are now being common in the European region, and we are doing quite well on that part as well. Next slide, please. Another just a picture to provide you idea how compact the control panel is, and if the operator is changing the cylinder, there are wall brackets we provide so that they can just hang the drive there, move the cylinders easily, and then bring back the drive on the cylinder. So it's a very nice, easy replacement of the cylinders and the drives. Next slide, please. So in summary, I would like to say that gas chlorination is not new technology. We have seen Wallis and Chen and Evoqua are the first manufacturers in the world who has brought this in 1913. From then, we have been using for 100 plus years. It has saved millions and millions people life. You can see what happened during the recent pandemic of COVID. I believe I would say that this was nothing when it was 70, 80 years back. People used to die from cholera and other waterborne diseases. But thanks to chlorine, that it's been now, case has become 1 to 10 million people. So it's a huge difference. But having said that, should not forget it is hazardous gas. It needs to treat with respect. And when we do that, it will give you a safe and reliable operation, whether it is a potable water or wastewater. We as a Evoqua Volunteer as are having a large installed base across the world. So there are 100 plus countries where we are installed. 55,000 plus installations are currently we know are operating, and then there could be many more. But having said that, we are being responsible manufacturer. We thought to bring in another quality good product, which would help our users, our customer, to go into that application in more safe and sound way. Next slide, please. So I thank you for your attention. Just in conclusion, it's quality product, another quality product, I would say, from Volunteer and Evoqua product family, and it will bring a peace of mind to you. So thanks again, and over to Suma.
Thank you, Shailesh. It was a very in-depth presentation about our emergency shut-off drive. I hope it gave a lot of insight to our audience as well. So now the session is open for question and answers. We have this, the mail IDs are on top. Since if we are not able to, if you want to send in your questions personally also, you can reach out to our product managers and the sales team as well. And we have our sales mail ID as well, sales.in@evoqua.com. And Remya and Kunwar are always here from the sales team to sales and engineering team to address your questions. And Shailesh Pawar also, like the product manager, who can address your questions as well. So we do have a couple of questions, Shailesh. So the first question is, can we fit ESD on common header line instead of each toner?
Yeah, so the idea of ESD is to minimize on the on the lines itself. So for the sake of mounting, we can do that. That's not a problem. But then what happens is the manifold line and the flexible tubing, which connects from tunnel to manifold, still remains exposed. So you will still have leakage points from that area, and that's why it's been preferred to fit directly on the cylinder, so there will not be any single point left below in the process. So theoretically, yes, but practically, I would not recommend.
Okay. So the next question is, do the chlorine sensors are hardwired, or can it be connected? Can it be connected without wires as well with the gas detector?
Chlorine sensors are always hardwired, and then they get connected to their own amplifier, because that's the standalone system. And from there, either people can take signal to A, scrubber system, B, emergency shutout drive system, or even C, for the ventilation system, where you can use ventilation at 2 levels, either to expedite it, higher changeover, or to close down. But to answer, the sensors are always hardwired to the amplifier.
Okay. So our next question is, can it work when connected to any other leak detection system, or should it be only Evoqua's gas monitoring system?
No, it can work with any other leak detection system. There is no restriction at all.
Okay.
So not necessary that it has to be VOPA. Any sound good detection system can provide a signal, and what we need is a digital potential free input, and ESD can operate with that.
Okay. Another question is there any specific requirement or a specification on the chlorine cylinder or toner valve to install ESD?
We asked two things. Number one is what is the dimension of that cylinder? If it is, sorry, not cylinder, the wall, and obviously the torque level, because torques are preset in the factory. The dimensions are required to confirm that the adapter unit that we are fitting with the drive is suitable for that wall. So as I showed in that table, there were some variants, like for example, Vanas, Techno, and one more wall from the Sherwood, for example, which is commonly used in APAC region. We already have those drives with us. If there are some different requirements, then we'll have to see and make a small tweak on the mechanical adapter side of the drive. So to answer in very short, the mechanical dimension of the wall and the torque level or closure torque level.
Okay. So the last question is, can data be recorded in case of leakage or emergency shutoff?
There is a limitation at the moment on that. We have this PLC. You can record up to 8 days, and I think that's the standard expectation from the client. But then obviously this will be connected to the main SCADA, which would having more recording or data storage facility, so it can be transferred there. So, but local plan is 7 days.
Okay. Yeah. So I guess there are no more questions. So we can, yeah. Yeah. So there are no more questions, I guess. So can end the presentation. I mean. Yeah.
Thank you once again, all, and
Okay.
thank you so much.
Thank you. Thank you, Shailesh, and thank you, Ramya, for joining this presentation. Thank you all for being part of this presentation.